Lesson 422, building two-way frequency tables. So here we have, we want to create a frequency table from data already given, and then we're going to answer a couple questions about it. So here is Wolverine's table. So this whole thing right here, Wolverine's table. Okay, so first thing we want to do is we want to fill in the blanks just so we have a full chart. Okay, so pretty much simple algebra. We're looking for this here. So the good plus the bad equals 111. So good plus the bad equals 111. Right? Then we subtract 84 from both sides. Subtract 84. And 111 minus 84 gives us 27. So here we have 27. Okay, now same thing for the humans. You got to figure out what's missing in here. So 43 plus what number gives us 52? So we can just take 52, subtract 43, and that gives us 9. Okay, and now for the aliens, notice we don't have a total for the aliens, so we can't go by the column. We're going to have to go by rows here. So we notice this is a total of 72, so that means 23 plus 43 plus this number gives us 72. So I'm going to work backwards. I'm going to take 72 and subtract 43 and 27. Right? So I'm going to take my 72 and I'm going to subtract 43 and I'm going to subtract 27, and that gives me 2. So I'm going to put it in 2 there. And then finally, I can figure this out. I can figure it out two ways. I can do it horizontally this way now, where I take 200 and subtract everything here. Or I could just do 35 plus 2 gives me 37. Okay, and you always want to check your math. 43 plus 9 gives me 52. Does this all add up to 200? So let's just fill in this last box here. We got 84 plus 9 gives us 93, plus 35 gives us 128. So now let's just check to confirm. Is 128 plus 72, does that give us 200? That does give us 200. And let's just confirm this way as well. 111 plus 52 plus 37 gives us 200 as well. Okay, so just a quick little recap. So mutants, this is the total of our mutants. It's going to be down here. Total 112 humans. That's our total of humans right there. Aliens right there. And then if we're looking at it from through the rows, so good people, we have a total of 72 good people. Bad people, we have a total of 128. And total people is 200. Okay, so just a quick way to read the table. So let's look at question number 1. It says, what is the probability of picking a mutant at random from the people Wolverine knows? So we're concerned about picking a mutant. So picking a mutant at random from the people who he knows. So he knows a total of 200 people. So we know that that fraction is going to be out of 200. Now, how many mutants do we have? So out of these 200 peoples, we have a total of 111 mutants. So the probability of picking a mutant is 111 divided by 200, which is 0.555. Okay, and you can change that to a percent. 55.5%. Up to you. Okay, now number 2. I'm going to rewrite the 200 in the. All right, number 2. What's the probability of picking a good human? So I'm going to do number 2 here. Probability of picking a good human. So good humans, so they have to be good and they have to be human. So if they're good and they're human, notice that these are humans, these are good, right? These 43 people are both good and they're human. So the chances of picking a good human are 43 total, right? Good humans out of the population is 200. 43 out of 200 gives us 0.215. That's the chances we have of picking a good human. All right, 3. what is the probability of picking someone who is bad? Okay, so they're just bad. So total bad people, we have 128 out of a population of 200. So 128 out of 200 gives us 0.64. Right, and it makes sense. Wolverine fights crime, so majority of the people he knows are bad guys. Okay, and our challenge question, which category of individual has a 1% chance of being selected? So 1%, that's a fairly low chance of being selected. So if we look, what we want to do, how to solve this, is we're going to take each one of these and divide it by 200. And that gives us the total for these rows, for the chart, for that little box. So for example, 27 out of 200, 0.135. So this is a 0.135 or a 13.5% chance of getting picked. That's not 1%. 1% is actually going to be here in the alien section, right? So if you take 2 and you divide it by 200, that gives us 0.01, which if you change to a percent, it's 1%. So good aliens. So chances are if you encounter an alien, it's not going to be a good one. All right, now creating a frequency table from a Venn diagram. So Forrest has a box of 12 candies. I'm going to box 12 because I know the total amount of candies I have in this box are 12. So if we get a number less than 12, imagine you just opened it fresh. If you get a number less than 12, or if you get a number greater than 12, then you know your math is a little wrong. So 12 candies in this box. The Venn diagram below shows how many candies contain chocolate, coconut, both, or neither. So let's complete this two-way frequency table. So now, contains chocolate. So if we're looking at this box here, which ones contain chocolate and contain coconut? So we could do it either picking out the information from the Venn diagram and moving it onto here, or we could just fill in the boxes, but we'll just fill in the boxes. So contains chocolate and contains coconut, right? Contains chocolate and contains coconut. So contains chocolate and contains coconut are going to be the ones in here, right? These are the ones that contain both. So we have a total of 3. Let's do contains coconut and does not contain chocolate. So it only contains coconut. So only contains coconut is 1. We can't say this here because it does contain chocolate, right? Those candies kind of have a combo. You get a little bit of both worlds. You get chocolate and you get coconut. So you can't say that 3 is not included. So we only have that 1. Okay. Now let's move up to this top right box. Does not contain coconut and only contains chocolate, right? No coconuts, contains chocolate. Contains chocolate are 6. Okay, and the theory goes the same. We can't claim the 3 here because those contain coconut, right? We do not want coconut. And last, does not contain coconut and does not contain chocolate. So we look at this little lonely 2 out here that's not included in any of the chocolate coconut goodness. So I don't know, it might just be like a scoop of peanut butter or something, but it doesn't contain coconut or chocolate. And just to do a quick count, just to count these up, 3 plus 6 is 9. So the total here is 9. 2 plus 1 is 3. So overall total is 12, right? And then let's do the total over here too. 3 plus 1 is 4. 6 plus 2 is 8. And just to confirm, 4 plus 8 is 12. 9 plus 3 is 12. So our chart makes sense. Okay, now when something's missing, so let's look at this one. So Nikita knows the following information about her food club that has 11 members. So we have 11 members. 3 members like neither fruit nor vegetables. 4 members like fruit but not vegetables. And 5 members in total like fruit. So before we go on, I'm just going to write my little totals here because we're going to want to see totals. Okay. So let's start transferring the data over. So 3 members like neither fruit nor vegetables. So do not like fruit, do not like vegetables. They're probably just meat eaters. So do not like vegetables, do not like fruit, 3. Okay. Now next, 4 members like fruit. So like fruit, now I'm looking here, but do not like vegetables. So do not like vegetables, we're looking at 4. Right, like fruits and do not like vegetables. Now, a little bit trickier. So 5 members in total like fruit. So like fruit, total, we have 5. Okay. Which means 1 would go here, right? Because 1 plus 4 gives us 5. So that kind of was a little given. Now we can do the totals here. That's 7. And remember that we have a total of 11, right? So the ultimate total that we have is 11. So now that means that we can find this value here, right? So what plus 7 gives us 11? Or you know that all these have to add up to 11. So right now we have 3 plus 4 is 7 is 8. So we're missing 3. So that means 3 would go here. But we could look at it. We could look at it whichever way that you would like, whichever way helps you, right? So we know that that total there is 4. So then that would have been 3. And lastly, 3 plus 3 is 6. And just to confirm everything, 5 plus 6 is 11. 7 plus 4 is 11. All right, creating relative frequency tables for the whole table from a two-way frequency table. Okay, so below is a table of people in the park and the activities that they do. Complete the frequency table below based on the total participants. And first we got to, of course, complete the table. Okay. So I can get the total here, 9 plus 11, that gives me 20. 4 plus 1, that gives me 5. 10 plus 15 gives me 25. Let's see, 9 plus 4 is 13, plus 10 is 23. 11 plus 1 is 12. 12 plus 15 is 27. So there we go, we have it completed. So now, we want to create the relative frequency table, and that's going to be the one down here. So relative frequency, that means that we're just finding what the frequency is for each one of these, or the probability that that one gets picked for all 50 people. So we're going to divide each box or each cell by 50. So we're going to take the 9 divided by 50. 9 divided by 50, and that gives us 0.18. So we have a 0.18 chance of this person getting picked. Let's go down to the females. So that's 11 out of 50 total. That gives us 0.22. Right? Because this is asking us for the total people. So we're using the total amount of people. Okay. Now the total of that section, 20 out of 50, gives us 0.4. So we're taking these numbers and just writing their frequencies down. So 4 out of 50 gives me 0.08. 1 out of 50, 0.02. 5 out of 50 is going to be 0.1. 0.1. My picnic guys, 10 out of 50 is going to be 0.2. 15 out of 50 is going to be 0.3. 25 out of 50 is going to be 0.5. 23 out of 50, 0.46. 27 out of 50 should be 0.54. and this here, total would be 1. Right, so that's the same as 100%. Okay, next one. So it says 50 students in the 8th grade class were asked what kind of ice cream they like, vanilla or chocolate. So we got a vanilla or chocolate right there. And what kind of toppings they like, sprinkles, M&Ms, or nothing. Identify any trends in the data. So we want to start looking at our data. So let's look at vanilla. So vanilla, 9 like sprinkles, 9 like M&Ms, 9 like nothing. There's not really a trend there. Those numbers are kind of 8 and 13 are a little too far apart to make any statements. 7, 9, and 4 for chocolate. Again, 4 and 9 are a little too far apart to make any statements. But now if you look at the totals of all these, we got 16, 17, and 17. So the totals, we can say that it's pretty much even. So the topping choices are even. So we could say the liking of toppings, oh, there's no E there, are similar. Okay. Now it wants us to create a relative frequency, a two-way table with percents, and we want to use the total number of students. Okay, so still we're going to be using the 50. This one's 50 as well. And we're going to do the same thing. So 9 divided by 50 gives us 0.18. So go ahead and fill that out. Let's pause the video while you do it, so we're not wasting time. All right, so there are the frequencies that I put in for each cell. And now let's answer the following questions. So we want to state the percents. So we'll write down the frequencies and then change it to percents. So the probability someone likes vanilla and sprinkles. So vanilla and sprinkles, that's 0.18. So we have our 0.18, change that to a percent. We're looking at 18% of people are there. Okay. Let's do vanilla and M&Ms. So vanilla and M&Ms, we're looking at here, right? They like vanilla and they like M&Ms. So vanilla M&Ms, we got 0.16. And of course, that's going to be 16%. Vanilla and nothing, that's 0.26 or 26%. We got chocolate and sprinkles. Chocolate and sprinkles is 0.14 or 14%. Chocolate and M&Ms is 0.18 or 18%. Chocolate and nothing looks like it's at 0.08 or 8%, right? This one's 1, 2, and you're just left with 8. Okay, so now a relative frequency table for the rows. Divide each number in each row by the total in that row. So we got to kind of have to go back and get the numbers that we have up here. Oops. Here. And we got to input them over there. So I'm going to pause again and take some time to transfer these numbers over. Okay. So remember, rows, we're looking at vanillas, and then we're looking at chocolate, right? So rows go left and right. So when we're looking for a frequency of a row, let's say that is asking for sprinkles given vanilla. So for given vanilla, then we're just looking at the vanilla guys here. So our denominator is going to be 30. Right, so for given vanilla, we know that it's 30. I'm going to write small because it looks like we need a lot of room for, well, there's 3 that are squished together. So given vanilla, how many of those people picked sprinkles? And that's 9, right? Because we're only restricting our data to people who like vanilla. So that's 9 out of 30. See, 9 out of 30 gives us 0.3, which as a percent, if you move it twice, 1, 2, you got to fill that in, it's going to give us a 30%. Okay. Now let's do M&M's given vanilla. So it's going to be the same thing. If it's given vanilla, that's going to be our denominator. Given vanilla, how many people like M&M's? 8. So 8 out of 30 gives us 0.26, and that's forever. So if we change that to a percent, it's going to be 26.6%. Okay, and now last one, which they like nothing given vanilla, that's 13 out of 30. 0.433 forever, and as a percent, that is 43.3%. Okay, and I'm going to go through these ones pretty quick. Sprinkles given chocolate. So this time we're just looking at chocolate. So given chocolate, so that's 20. How many of them like sprinkles? That's 7. So 7 out of 20 gives us 0.35 or 35%. Given chocolate again, M&M's, that's 9. 9 out of 20. Ooh, 9 divided by 20. 0.45, which is 45%. And then nothing in chocolate, that's 4 out of 20. That is 0.2. And that is 20%. Okay. So if we add these all up now, so all these here, that should equal pretty darn close to 100%, right? So 30 plus this is 56. That's 99.9. This here is an exact 100. Okay. So now for the columns, so this time columns, we're looking at the vertical ones. So we're doing the same thing, just vertical this time. So I'm going to, oops, not do that. I meant these. Okay. So again, I'm going to transfer over the information. So quick pause. Okay. So this time our totals are on the bottom here. Okay. And we're going to be doing column frequency. So given sprinkles, so we're just looking at sprinkles here. Total sprinkles, we have 16. That goes on the bottom. How many like vanilla? 9. And then I'm going to let you guys go ahead and do the decimals and percents. I think you got that down by now. Okay, so now given vanilla, given M&M's. So given M&M's we got 17 total. And how many of those like vanilla? We got 8. And then we got nothing. 17 total people like nothing. And 13 of them like vanilla. Sprinkles. It was 16. How many of those like chocolate? It was 7. Given M&M's, that's 17. How many of those like chocolate? 9. And given nothing, how many of those like chocolate? 4. Okay, so all you have to do is divide those out, get the decimal, and then get the percent, and you have your column frequencies.